November darkness settled over the landscape. Near the small village of Neuchâtel, along the muddy riverbank, an elite armored regiment from the Waffen-SS Panzer Division had constructed what they believed was an impenetrable killing field. The strange contraption that arrived with the morning reconnaissance patrol looked like a failure before it even fired its first shot. This peculiar weapon represented the Allies' only hope against the massive concrete fortifications that dominated the terrain. The SS soldiers openly mocked what they called the Americans' paper tube because of its flimsy, unreliable appearance. But the men carrying this odd device would soon unleash its horrifying ability to transform solid concrete bunkers into underground death chambers. The vital crossroads at Neuchâtel sat squarely within the most heavily defended section of the riverbank. This position had become the crucial pivot point of the entire autumn military campaign. The Allied Timberwolf Division found their advance toward the German border completely stalled. They faced a masterwork of defensive engineering designed by SS Brigade leader Heinz. Heinz was a hardened veteran who had survived the brutal defensive campaigns on the Eastern Front. Through bitter experience, he had learned one terrible lesson about warfare against the Americans. In open terrain, the American forces simply could not be stopped. The Americans had to be lured into a trap. Breaking completely with traditional German military doctrine, Heinz issued orders to abandon the standard static trench systems. Instead, his engineers constructed an elaborate network of interlocking fire positions. 14 massive reinforced concrete bunkers formed the backbone of this defense. Each bunker featured walls measuring up to 6 feet in thickness. These structures were arranged in a precise checkerboard pattern across a narrow, waterlogged floodplain. The only route of approach crossed completely open ground. This killing field was perfectly positioned for devastating machine gun crossfire from multiple angles. At the heart of the defensive system, hidden beneath what appeared to be an abandoned farmhouse, lay the main command post and medical facility. This underground complex was protected by enough reinforced masonry to survive a direct hit from the heaviest artillery shells. Standard Allied assault tactics had proven devastatingly effective since the breakthrough at Normandy. But here at Neuchâtel, these proven methods were failing catastrophically. Artillery bombardments that easily destroyed earthwork fortifications barely scratched the paint on these concrete fire positions. The main guns from the accompanying Sherman tanks lacked sufficient penetrating power to breach the thick reinforced concrete at effective range. Direct infantry assaults, which typically relied on satchel charges and portable flamethrowers, were being neutralized before the attackers could reach their objectives. The SS engineers had designed their firing apertures to be extremely narrow and sharply angled. This prevented any portable weapons from being inserted through the openings. After 7 days of determined fighting, the Allied forces had suffered over 800 casualties while gaining absolutely zero ground. The division commander, watching his strength bleed away, desperately needed a miracle. Intelligence reports from a captured German engineer confirmed what the Allied leadership feared most. This revolutionary defensive concept had been calculated to counter every American weapon currently deployed in the field. Heavy artillery, tank guns, and portable infantry weapons had all been factored into the defensive equations. The Germans had created what amounted to a mathematically perfect fortress. The Japanese defenders at Saipan had proven that static defensive positions could exact a terrible cost in American lives. But Heinz had proven something far worse. Concrete and terrain, properly utilized, could actually defeat overwhelming firepower. The single weapon system that the SS defenders had not accounted for was one that the Americans themselves considered a transitional failure. This new, temperamental device had been brought to the front lines by a small reconnaissance engineering unit. The weapon had not even been formally designated for use against fortified positions. This was the experimental anti-tank launcher, mockingly nicknamed the Dragon's Tooth by the Ordnance Corps. The nickname came from its oversized, oddly shaped warhead and its notorious, bone-jarring recoil. The weapon was fragile beyond belief. Its firing mechanism routinely failed in damp weather conditions. Its accuracy beyond 50 yards was essentially non-existent. SS troops who had observed American training films had watched their own soldiers laugh at the weapon's cumbersome, unwieldy nature. To the German defenders, this represented nothing more than a sign of American desperation. But this experimental launcher carried one crucial technical secret that distinguished it from standard anti-tank rounds. The hollow charge kinetic impact payload had been developed initially by a specialized metallurgical team working at the Detroit Arsenal. The warhead contained a precisely shaped charge that, upon contact with a target, detonated a carefully formed lining of pure copper. The explosion focused this copper into a hypervelocity jet of superheated, plasticized metal. This design concentrated maximum pressure at the exact point of impact, creating a tiny but incredibly intense localized breach in even the thickest armor. Most importantly, the field engineers, specifically a resourceful captain named Vance, who possessed extensive background in structural engineering, immediately recognized the untapped potential of this seemingly flawed weapon. The blast effect was far too small to destroy an entire bunker through conventional means, but its highly specialized nature meant it was not attempting to destroy the wall at all. Instead, it was designed to punch a needle-thin hole straight through solid concrete. Captain Vance's engineering team focused their innovative efforts not on modifying the launcher itself, but on completely revolutionizing the ammunition. They dramatically increased the density of the copper lining material. Against all official warnings and safety protocols, they slightly destabilized the explosive filler. This ensured a much wider and more intense thermal pressure wave following penetration. Their tactical plan was radical and completely contradicted 3 years of established demolition doctrine. The team would not attempt to destroy the concrete fire positions through brute force. Instead, they would exploit the one critical vulnerability that all modern concrete structures share without exception: internal air pressure dynamics. The experimental launcher's copper jet could penetrate the wall, creating a clean, precise breach point. Through this tiny opening, they would immediately insert their newest invention. The compression tube was a simple but deadly spring-loaded piston device. It carried a high-yield white phosphorus charge combined with a secondary concussion grenade. The theory behind this approach was absolutely devastating in its simplicity. The experimental round creates the initial breach. The compression tube gets inserted and immediately fired. The resulting blast and intense heat, completely contained within the sealed concrete chamber, would instantly overpressurize the entire bunker. Even if the SS troops somehow survived the initial blast effects, the rapid pressure spike and immediate oxygen depletion would render their position completely uninhabitable. The SS engineers had calculated their defenses to withstand external explosions and conventional fire attacks. They had never considered the possibility of catastrophic, instantaneous internal rupture. The ridiculed paper tube was about to become the ultimate dragon's tooth. November morning. Fire position Delta 6. The deployment process was agonizingly slow, requiring painstaking precision and a complete reversal of all standard operating procedures. The infantry units did not charge forward in a conventional assault. Instead, they functioned as highly specialized spotters, carefully identifying blind spots between the overlapping SS machine gun arcs of fire. A two-man team, led by Sergeant Kendrick, advanced under dense smoke cover to within 200 yards of the target. This was the maximum distance where the SS defenders felt completely safe, and the experimental launcher remained marginally accurate. Kendrick's first shot was a near miss. The round impacted the earth directly beside the bunker, causing the weapon's notoriously dangerous firing mechanism delay. The SS position briefly ceased fire. The garrison inside was likely laughing at the weapon's apparent failure and the Americans' desperation. Kendrick's second shot, fired exactly 1 minute later, was absolutely perfect. The round struck the face of Delta 6, precisely where the concrete was thickest and most reinforced. There was no huge, satisfying explosion that would normally accompany a successful hit. Just a sharp, metallic crack and a tiny puff of concrete dust. The SS unit commander inside immediately radioed a brief, mocking report to his headquarters. Enemy firing flares from paper tubes. No damage sustained. Resume normal fire patterns. But Kendrick's two-man team was already moving into the next phase of their attack. The second soldier, Private Harris, sprinted forward carrying the compression tube device. He quickly located the clean puncture wound in the concrete. It looked like a needle hole in a massive concrete haystack. Harris plunged the tube deep into the opening. The spring mechanism automatically set the charge at maximum depth. Half a second later, the morning silence was completely shattered by a muffled, inward imploding boom that seemed to come from underground. The effect was immediate and absolutely catastrophic. The massive concrete walls visibly shuddered from internal pressure. Thick, white smoke from the phosphorus charge shot out of every firing aperture, every structural seam, and every microscopic crack in the reinforced concrete. The roof of the bunker visibly bulged upward a full inch before settling back into place. When the clearing team cautiously approached the position minutes later, they discovered all personnel inside Delta 6 were dead. The SS soldiers had not been killed by shrapnel or direct heat exposure. Later autopsies confirmed massive internal trauma caused by the sudden, intense pressure spike within the sealed chamber. Their position, originally designed to be completely impregnable from external attack, had been transformed into a pressurized death chamber through internal explosion. Over the following hours, Kendrick's specialized teams worked under cover of sustained artillery barrage to mask the distinctive sound of the experimental launcher. They systematically reduced 14 separate fire positions using identical tactics. The SS radio communications, initially filled with mocking references to the paper tubes, rapidly turned frantic and desperate. Messages intercepted by Allied intelligence units documented a complete descent into panic among the German defenders. Delta 6 silenced with no sign of external fire damage. Request immediate explanation. This was followed by increasingly desperate transmissions. The tubes are systematically killing us. They make the concrete walls collapse from inside. The German command believed the Americans had developed some form of geological weapon rather than a simple shaped charge system. The psychological breakdown among the defending troops was rapid and complete. The entire defense system, built on absolute faith in reinforced concrete protection, was literally collapsing from within its own walls. Before we continue with this incredible story, tell us where you're tuning in from today. If this amazing piece of history touches you, make sure you're subscribed to our channel. Tomorrow, I've saved something truly extraordinary for you that you won't want to miss. The localized collapse of a single fire position sent immediate shockwaves throughout the entire SS command structure. Brigade leader Heinz, secure in his underground command post below ground level, initially dismissed the field reports as nothing more than panic from inexperienced junior officers. His defensive geometry had been calculated to mathematical perfection. These positions were theoretically impossible to neutralize without massive siege weapons or sustained heavy bombardment. But as the radio intercepts grew increasingly frantic and then fell completely silent, one fire position after another, Heinz was forced to confront the terrible reality that his mathematically unassailable fortress was systematically dissolving before his eyes. On November 15th, a German field patrol recovered the bodies from the Delta 6 garrison for detailed examination. The inspection revealed the precise, surgically small entry point and the grotesque internal injuries to all personnel. Heinz's engineering staff, completely stunned, suddenly realized the Americans had not employed a bigger, more powerful gun. They had developed a smarter, smaller weapon system. The captured Japanese military doctrine on the effectiveness of portable flamethrowers had heavily influenced the German defensive design. But the fundamental assumption was that any enemy weapon would require large access points to be effective against bunker positions. German engineers had never considered the possibility of a weapon that could create its own microscopic breach point and then exploit the sealed environment of the bunker itself as a killing mechanism. Heinz's command post was specifically designed to withstand anything short of a direct airstrike from heavy bombers. His defensive operational order, officially designated Stahlgeist or Steel Spirit, dictated that forward units must hold their positions at all costs. This would force the Americans to bleed themselves white against impregnable concrete. However, the psychological mechanism of defeat proved far more devastating than any physical destruction. The remaining two forward fire positions were abandoned not because they had been successfully attacked, but simply at reports of Sergeant Kendrick's teams advancing in their direction. In an unprecedented breakdown of military discipline, SS troops who believed they faced an unstoppable internal explosion device simply fled their positions. They abandoned supplies, weapons, and wounded comrades in complete violation of the rigid SS Warrior Code that demanded death before retreat. The Division Intelligence Section, continuously monitoring captured radio communications, documented this cascading collapse in fighting morale. Interrogations of the few German prisoners confirmed the absolute terror that had gripped the defenders. They no longer referred to the experimental weapon as the paper tube. Instead, they called it the Shatterer, or the Whisper of Death. This was because the attack was often completely silent. Just a small metallic crack, followed by the sudden, terrifying internal explosion. For the first time on this entire front, elite SS troops were actively choosing capture over remaining in their prepared, reinforced concrete defensive positions. Heinz, watching his defensive masterpiece systematically transformed into a death trap, found himself completely cornered. His supposedly impregnable command post had become a liability rather than an asset. On November 16th, he radioed Panzer headquarters requesting permission to execute a tactical withdrawal from the entire sector. This act directly violated his core operational orders and SS doctrine. The request was immediately denied by higher command. His final decision, documented in a recovered field notebook, was a desperate, doomed attempt to launch a counterattack against the American positions. Heinz and his remaining troops attempted a final suicidal breakout from their underground command complex. They hoped to destroy the experimental weapon teams before they could target the command post's vulnerable ventilation shaft system. This last-ditch effort would prove to be their final mistake. The successful neutralization of the forward fire positions led to immediate battlefield modifications and the establishment of completely new tactical doctrine. Captain Vance's reconnaissance engineers, now officially designated the Assault Pioneer Platoon, were no longer merely supporting conventional infantry operations. They had become the spearhead of the entire attack. Their operational tactics evolved rapidly, mirroring the systematic precision that had come to define American industrial warfare. The SS command post, located deep beneath the abandoned farmhouse, presented a new and significantly more challenging target. The concrete was substantially thicker than the forward positions. The entrance tunnel was sharply angled and heavily protected by multiple defensive layers. The engineering team determined that a frontal assault would be both unnecessary and prohibitively risky. Instead, they developed what became known as the seismic triangulation technique. This innovative approach utilized rudimentary ground vibration detectors, originally designed for oil exploration operations, to create detailed maps of the underground tunnel system. This technological adaptation gave Kendrick's teams precise three-dimensional targeting data for the first time. The new tactical approach focused not on the massive concrete walls, but on the seemingly insignificant ventilation shafts. SS designers had positioned these critical air shafts in seemingly innocuous locations. One was hidden beneath a large oak tree. Another was cleverly disguised as an old farmhouse chimney. The German engineers believed their small size protected them from anything except a direct artillery hit from heavy guns. The experimental launcher was employed at extended range, with Sergeant Kendrick's team carefully refining their launch angle calculations. Their target was not to penetrate the shaft's small concrete cap through brute force. Instead, they aimed to completely obliterate the protective cap and open the shaft for a secondary attack phase. The precisely aimed shot struck home perfectly. Field reports documented the devastating effect immediately. The concrete cap completely disintegrated, opening a vertical access hole directly into the underground complex. Instead of using the standard compression tube device, the engineering team had developed a scaled-down delivery system specifically for this type of target. The thermal gas canister was designed to be dropped down the vertical shaft. This specialized canister released a superheated, rapidly expanding cloud of dense thermal gas. The chemical mixture was specifically designed to immediately consume all available oxygen and incapacitate any personnel in the confined underground space through oxygen deprivation. This final tactical maneuver proved swift and absolutely decisive in its execution. After-action reports documented thick smoke and gas emerging from dozens of previously unidentified exits throughout the area. This confirmed the full extent of Heinz's elaborate deep tunnel system that connected multiple underground chambers. The systematic neutralization of the command post occurred within minutes of successful target acquisition. Heinz's final, desperate breakout attempt was cut short by the gas attack before his troops could even reach the surface exits. This trapped his remaining force deep underground with no possibility of escape or survival. The only American casualties sustained during this entire complex operation were 2 soldiers who suffered minor wounds from stray small arms fire during the initial suppression phase. The final result was complete, systematic destruction of a defensive system that had previously cost hundreds of American lives. This tactical victory was achieved with absolutely minimal risk to attacking forces. The forgotten, fragile experimental launcher had successfully transformed static concrete defense into an immediate death sentence for any defenders foolish enough to remain in their bunkers. The tactical success of the specialized launcher teams represented only half of this remarkable story. The true triumph lay in the industrial and logistical support systems that sustained the entire operation from behind the front lines. The original experimental weapon had been designed as a disposable, single-use system, but its modified ammunition, featuring the copper-lined hollow charge rounds, represented a high-demand extremely low supply item throughout the supply chain. Each individual round required specialized materials and meticulous hand assembly at regional ordnance depots located far behind the active combat lines. The munitions resupply platoon, representing the truly unsung heroes of this operation, developed a sophisticated rapid supply chain management system. This was based entirely on constant battlefield feedback and real-time tactical requirements. These logistics specialists did not simply move ammunition boxes from point to point. They managed a complex chemical manufacturing process under combat conditions. Initial operational problems included the discovery that the rounds were dangerously sensitive to altitude changes during long-distance transport. These changes destabilized the explosive filler compound and rendered the ammunition completely useless. The solution, implemented within hours of the first successful bunker breach, involved shipping all rounds in specially designed, pressure-regulated containers. This required dedicated transport trucks and absolute priority clearance on heavily congested supply roads. Furthermore, the compression tubes and thermal gas canisters were developed and manufactured almost entirely under field conditions using improvised materials. Vance's engineering teams utilized captured German metalworking equipment and carefully repurposed salvageable parts from damaged American vehicles. These materials were used to fabricate the complex piston and spring mechanisms required for the compression tube system. This represented industrial adaptability at its absolute finest. A complete microfactory had been established within miles of the active front lines. This facility constantly refined and improved the specialized weapons and secondary tools required for the mission. Military logistics records trace the direct lineage of this remarkable innovation. The ability to rapidly produce and deploy highly specialized munitions for extremely specific tactical problems had never been demonstrated before at this scale. The Japanese military had faced America's overwhelming industrial capacity primarily in the form of mass-produced tanks, aircraft, and naval vessels. Brigade Leader Heinz faced that same industrial might in the form of precision, localized engineering, and adaptive logistics systems. A single concrete fire position might require up to 20 experimental rounds and 15 compression tubes to neutralize completely. Sustaining the systematic reduction of an entire defensive sector required thousands of these specialized, handmade items delivered exactly when and where they were needed. Post-war logistical analysis confirmed that the SS supply chain, based on rigid centralized production and slow, inflexible delivery methods, could not possibly match this American localized industrial response capability. Heinz's defensive genius was ultimately negated not by the raw destructive power of the initial shot, but by the absolute guarantee that the right shot would arrive at exactly the right time and place. Each round was perfectly calibrated for its specific target and tactical situation. The ultimate victory belonged to the supply planners and truck drivers every bit as much as to the combat engineers and gunners on the front lines. The psychological impact of the experimental launcher and compression tube system on SS defenders proved profound and lasting, extending far beyond the immediate physical trauma of the attacks. This weapon represented a form of architectural betrayal that struck at the very core of defensive psychology. For the German troops, their fundamental faith rested in thick, cold concrete that promised absolute invulnerability against enemy attack. The experimental launcher did not simply defeat these men militarily. It transformed their sanctuary into an inescapable underground coffin. Post-war interrogations of surviving SS soldiers revealed persistent feelings of disbelief and absolute terror that lasted for years after the war ended. One survivor testified that facing conventional artillery bombardment was war, as they understood and accepted it. You hear the incoming shell, you take cover, you survive, or you don't. But the experimental launcher was fundamentally different from any weapon they had ever encountered. You hear only a tiny tap against the wall, and then the air itself attempts to kill you. The protective wall, your trusted friend and ally, suddenly becomes your deadliest enemy. This weapon completely contradicted their entire concept of military service, combat survival, and defensive warfare. This psychological defeat led directly to the unprecedented mass surrenders that followed. In all previous engagements throughout the war, SS units had been known to fight literally to the last man, rather than accept capture. At the riverside positions near Neuchâtel, wholesale surrenders occurred as a direct result of complete psychological defeat. This confirmed American intelligence assessments that elite SS units were actually choosing self-preservation over death when faced with the internal collapse mechanism that turned their bunkers into sealed death chambers. For the American troops who operated this experimental weapon system, the combat experience carried a unique and heavy moral burden that affected them for years. Military chaplain reports documented dramatically increased requests for psychological counseling from Sergeant Kendrick's specialized teams. Unlike conventional artillery fire or standard tank combat, the experimental launcher operation was intensely intimate and surgically precise in its killing method. The weapon crews knew with absolute certainty that they were effectively sealing enemy soldiers alive within a confined space and then killing them through internal pressure and suffocation. This moral duality created lasting psychological trauma. The crews understood that their weapons saved countless American lives by ending the stalemate quickly and efficiently. But they also knew they were inflicting a terrifying, inescapable death on fellow human beings trapped underground. This complex moral burden haunted many of the gunners long after the war had ended, and they had returned to civilian life. The official after-action review specifically acknowledged this unprecedented moral ambiguity. The experimental weapon system was absolutely decisive in reducing American casualties on our side of the engagement. However, the specific nature of the killing method proved deeply distressing to the personnel directly involved in its operation. This psychological cost factor must be carefully considered and factored into all future doctrinal development and weapon deployment decisions. The lasting legacy of the experimental launcher at Neuchâtel therefore represented far more than a simple tactical footnote in military history. It became a crucial lesson in the devastating effectiveness of psychological warfare conducted through technological means. The German defenders had designed their entire defensive system based on superior physical strength and structural engineering. The Americans systematically defeated this approach by developing a weapon that primarily destroyed the defenders' mental fortitude and their fundamental belief that any fortified position could provide safety from American technological innovation. The once ridiculed paper tube had been transformed into the ultimate symbol of technological dominance that rendered individual courage and fighting spirit essentially meaningless on the modern battlefield. The decisive battle for the Neuchâtel crossroads finally ended on November 18th, after 6 intensive days of combat following the experimental launcher's initial deployment. The immediate tactical lessons learned from this engagement were rapidly integrated into Allied advance operations across the entire European theater of operations. The experimental launcher, previously scheduled for obsolescence and replacement, was immediately given highest priority for mass production. The hollow charge round became standard issue equipment for all anti-fortification specialist teams. The Assault Pioneer Platoon's innovative seismic triangulation technique became mandatory curriculum in all Allied engineering schools and training programs. The strategic military consequences of this tactical breakthrough were absolutely massive in scope. The successful penetration of German defenses at Neuchâtel completely eliminated the crucial hinge point of enemy resistance along the entire riverside sector. This breakthrough allowed Allied forces to advance over 200 miles in the following week alone. Military planners estimated this success shortened the overall campaign in that sector by at least 3 months of intensive fighting. Joint Allied staff estimates indicated that the experimental launcher and its modified tactics directly prevented potentially thousands of Allied casualties. These calculations were based on initial expected loss ratios of 50 casualties per fortified position using conventional assault methods. The General Staff's comprehensive post-war assessment of the Neuchâtel operation reached a fundamental conclusion about modern industrial warfare. Technological adaptability multiplied by precision logistics equals inevitable victory, regardless of individual human courage and fighting determination. Heinz's troops possessed exceptional courage and fighting skill, but they could not overcome the small, localized industrial machine that continuously manufactured, delivered, and improved the perfect counterweapon in real time under battlefield conditions. Today, the quiet agricultural fields near Neuchâtel, now returned to their original French name of Neufchâteau, remain peaceful and productive. The massive concrete fire positions, deemed too expensive and dangerous to dismantle completely, still stand as permanent scarred monuments to this forgotten battle. Some of these structures still clearly show the tiny, perfectly round holes that bear testimony to the moment when a seemingly broken and universally derided weapon fired a surgical shot that transformed a mathematically unassailable fortress into a series of pressurized underground tombs. The complete story of the experimental launcher serves as a powerful counterpoint to the more famous and celebrated weapon systems of the Second World War. It was not the biggest, loudest, or most glamorous weapon deployed during the conflict, but it proved to be the most tactically adaptable system when facing a specific engineering challenge. The SS leadership believed their concrete walls represented the strongest defensive positions in all of Europe. They discovered too late that when American technology flows through tiny openings like water or exploits the fundamental physics of confined spaces, all positional advantages are immediately negated. The final victory at the Riverside sector confirmed that when facing relentless American industrial ingenuity and adaptive logistics, warrior spirit and individual courage alone were simply not sufficient for victory. The extensive military documentation regarding the experimental launcher's performance in the Neuchâtel operation now resides within the National Archives, providing researchers with a complete operational picture. These records show exactly how a transitional, often ridiculed weapon system became a decisive force that changed battlefield tactics permanently. Official war diaries from the Timberwolf Division, detailed after-action reports, and comprehensive technical assessments provide complete operational records. These documents highlight the experimental launcher's unique success in solving what had appeared to be an impossible tactical problem. The Marine Corps official history credits the flame-throwing tank as the most significant tactical innovation of the Pacific Theater campaigns. For European theater breakthrough battles against fortified positions, military historians now recognize the hollow charge anti-fortification doctrine as the key technical innovation. This new tactical approach fundamentally altered infantry versus bunker combat for all subsequent operations throughout the remainder of the war. Crucially, the identity of the inventor of the most decisive tactical element, the compression tube system, was almost completely lost to military history. While the experimental launcher itself was a standard Ordnance Department project, the rapid field modification that made it absolutely lethal was entirely the brainchild of Captain Vance, the structural engineer mentioned in earlier reports. Post-war testimony from Sergeant Kendrick specifically confirmed Vance's relentless innovative drive and engineering brilliance. Vance recognized that effective military engineering was never about applying brute force solutions to tactical problems. Instead, success came from identifying and exploiting critical weaknesses in materials and structural design. Finding the tiny crack, the vulnerable air pocket, the single point of failure that could bring down an entire defensive system. Vance's engineering philosophy, documented in a single surviving technical journal recovered after the war, was elegantly simple in its deadly effectiveness. The enemy constructs a fortified structure specifically designed to resist our conventional artillery and standard weapons. But they forget that their structure itself becomes a perfectly sealed container for whatever payload we choose to deliver inside it. Our tactical challenge was simply to develop a specialized needle and an efficient method to deliver the poison through that needle. Captain Vance's innovative breakthrough was subsequently applied to urban warfare tactics in later operations throughout the European campaign. This proved conclusively that the fundamental principles developed on the muddy riverside near Neuchâtel were universally applicable to all types of sealed fortifications and defensive positions. By early 1945, the United States Army had established specialized target exploitation units based entirely on the Assault Pioneer Platoon's hard-won battlefield experience. These new units focused exclusively on precision penetration techniques and internal defeat mechanisms rather than traditional external destruction methods. The experimental launcher had evolved from a forgotten failure into the foundation of modern siege warfare doctrine. The T story reveals a brutal truth about warfare innovation. Victory doesn't always spring from massive military budgets or grand strategic plans. Sometimes success depends on one overlooked expert, a structural engineer thrown into combat conditions, someone who spots the weak point that raw firepower cannot find. The SS troops laughed at the T. They called it nothing more than a paper tube. Their mockery made Vance's brilliant adaptation even more psychologically devastating. Their ridicule became the ultimate evidence of how badly they misjudged American creativity and resourcefulness. These enemy soldiers couldn't grasp what was coming. They were about to learn a harsh lesson. American ingenuity would turn their greatest strength into their final weakness. Brigadier Hines made one last desperate move. He ordered a counterattack with his remaining forces. The attempt ended in complete disaster. His small unit was trapped and neutralized. The thermal gas had been pumped directly into their command post through the ventilation system. Hines died in that attack. His body was discovered inside the reinforced concrete chamber. He had placed all his faith in thick walls and solid construction. That trust was tragically misplaced. The very concrete he believed would save him became his tomb. German military reports captured during later campaigns told the whole story. These documents came from high command files seized during the Rhineland offensive. They confirmed beyond doubt that the T and its modified ammunition were decisive. The intelligence was brutally honest. Unlike other sectors where German officers denied reality and clung to outdated doctrine, the analysts studying the River List collapse provided a chilling assessment. One report came from a field marshal's aide. His words were stark and unforgiving. The Americans did not invent a bigger shell. They invented a smarter shell. They turned our best defense against us. Our concrete was our shield. Their technology made it a coffin. The T negated our entire defensive strategy. This harsh reality changed German defensive planning for the rest of the war. Commanders received new orders. They were told to create lighter defenses, more dispersed positions that could be abandoned quickly. No more massive investment in thick static bunkers. The lesson came too late. When facing American industrial adaptability, material strength was only temporary. The SS had spent 3 years preparing for conventional assault tactics. They studied British tank charges. They analyzed massive Soviet artillery barrages. But they never anticipated this weapon. It operated on physics principles and material science, not sheer explosive force. The ridicule they heaped on the paper tube became a bitter epitaph. These were men who died still believing in the power of their walls. Military history symposiums revisit the Neuchâtel scenario every year. The consensus remains clear and unchanged. The SS defenders showed determination and courage, but modern war follows immutable equations. The American ability to recognize flaws in their own equipment was crucial. The T had low accuracy problems. They transformed this weakness into decisive advantage through field innovation. The compression tube proved the overwhelming factor. German reliance on fixed defenses crumbled before fluid American innovation. The SS didn't die from tactical blunders. They died from impossible technological disadvantage. The T story at Neuchâtel created a lasting legacy. This weapon system was a decisive innovation. It saved thousands of American lives. It also inflicted a form of death that inspired terror and broke enemy morale completely. Admiral Chester Nimitz referenced similar breakthroughs in Pacific operations. He noted in a later report that victory often comes not from the largest weapons. It comes from the most perfectly tailored ones. The Army's speed in adapting their anti-fortification weapon at Neuchâtel was remarkable. It equaled the impact of deploying a full division. General Omar Bradley reflected on these lessons learned later. He emphasized the core concept of adaptability. The courage of German soldiers was never in question. But courage cannot defeat chemistry. Determination cannot defeat an engineer who has found fundamental flaws in your design. They relied on fixed materials. We relied on continuous innovation. The weapon's moral complexity persists to this day. Veterans' reunions documented by military historians reveal interesting perspectives. American soldiers express respect for the unwavering courage of SS defenders. Yet they defend the use of the T as painful necessity. The weapon created immediate and inescapable death. But it ultimately shortened the brutal campaign. The T proved a fundamental truth of industrial age conflict. Technological superiority can overcome human courage and determination. This happens when the disparity becomes overwhelming, especially in specialized tactical applications. SS survivors who eventually returned home carried invisible scars from this defeat. They realized their rigid faith was misplaced. Their belief in their fortifications and doctrine couldn't match American engineering ingenuity. It couldn't compete with the limitless capacity of the American supply chain that fed those engineers. Today, the T sits in museums as a historical artifact, but its lineage remains clear and traceable. Modern military doctrine for assaulting fortified positions still references principles established by Vance's team. Precision penetration followed by internal atmospheric or chemical defeat. The broken, ridiculed weapon that fired the shot that killed them all stands as permanent testament. In modern warfare, the most fearsome weapon isn't the one making the largest explosion. It's the one that targets the enemy's foundational belief in their own safety. The battle for the Riverless at Neuchâtel concluded with more than tactical victory. It made a profound statement on the nature of 20th-century warfare. Of the SS defenders commanded by Heinz, only a handful surrendered. All of them fled the advancing T teams rather than remaining in bunkers. The majority died when their impregnable fortifications became airtight, inescapable pressure chambers. American forces saw dramatic changes after the initial week of high casualties. Their casualty rate plummeted to near zero during the main assault on the fire blocks. The transformation was complete. From blind faith in frontal assault to recognition that technology could negate any positional advantage. The T story encapsulates the American war machine's decisive advantage: adaptability. This was victory achieved not by tanks or strategic bombers. It came from field-level innovation. A simple device: the compression tube paired with specialized rounds. This small-scale ingenuity was backed by world-beating industrial supply chains. It proved to be the ultimate force multiplier. Germans relied on fixed blueprints and rigid doctrine. Americans relied on structural engineers like Vance, men who could turn flawed weapons into surgical instruments of war. The SS ridiculed the T. They felt confident their concrete would stop any projectile. They failed to realize the projectile only needed to be smart enough to open the door. The legacy of Neuchâtel is simple, yet terrifying. Warrior spirit could not stop pressure waves. Courage could not overcome material science. Determination meant nothing when enemies could turn your fortress into a pressurized death trap. The SS discovered that in modern war's arithmetic, the technological variable matters most. When optimized for specific flaws, it can nullify all other human factors. The paper tube fired by Americans delivered a shot that proved technological adaptability is the ultimate route to victory. The battle for the Riverless at Neuchâtel was a small, brutal theater. It provided vast lessons for future warfare. Of SS defenders commanded by Heinz, only prisoners were captured. All surrendered specifically to avoid death by internal pressure. They had witnessed this fate in the fire blocks. American forces achieved final breakthrough with minimal casualties after the initial week of costly frontal assaults. The transformation was complete. From rigid faith in artillery to recognition that technological adaptability, backed by industrial capacity, was the ultimate variable. The T system wasn't a universal weapon. It was a perfectly tailored solution for one critical tactical problem. Victory came not from 50-ton tanks or strategic bombers. It came from resourceful engineers who adapted a broken weapon for specific surgical function. This small-scale ingenuity was backed by American supply chain capabilities. The ability to prioritize and deliver specialized field-manufactured components proved unstoppable. German command had staked defense on the immutable strength of concrete. They failed to realize concrete itself became the final trap. The ridicule they heaped on the paper tube measured their strategic failure. Today, near the village of Neuchâtel, concrete fire blocks remain as silent, scarred monuments. These are testaments to Heinz's failed doctrine. Many bunkers still bear tiny entry holes, permanent reminders of the moment the broken weapon fired a shot, proving technological adaptation is victory's ultimate route. The T legacy is profoundly simple. Warrior spirit could not stop pressure waves. Courage could not overcome material science. Determination meant nothing when enemies turned your fortress into pressurized death traps. The SS found that in modern war's arithmetic, technological variables matter most. When optimized for specific flaws, they nullify all human factors. The American paper tube fired shots proving technological adaptability leads to victory. Understanding the T's impact requires examining the industrial capacity that served as foundation. It wasn't just Captain Vance's field genius, it was the entire American production line's ability to pivot and support highly specialized small-batch military needs. The flame tank operation at earlier campaigns required massive fuel delivery. The T operation demanded precision chemistry and priority manufacturing. The unique performance of shaped charge rounds relied on specific metallurgical standards. The copper liner had to meet consistent specifications. This ensured hypervelocity jets formed correctly upon detonation. Even small failure rates would have meant disaster. Back in the States, chemical plants and munitions factories made dramatic changes. Initially focused on mass-producing standard artillery, they implemented high-precision quality control procedures specifically for T rounds. This commitment to small-scale perfection under wartime pressure demonstrated strategic advantage. The Germans could not fathom this capability. Furthermore, transportation infrastructure dedicated to the T system was a logistical marvel. Specialized pressurized containers required dedicated railroad freight cars. Special truck convoys transported them from production lines to forward depots in Belgium. Logistics officers treated the rounds like fragile laboratory specimens, not common ammunition. They understood that single failed shipments could stall entire offensives. Casualty rates would soar back to catastrophic numbers seen during the first week of fighting. This level of micrologistics contrasted sharply with other models. The Soviet approach emphasized overwhelming volume. The German model used decentralized resource, scarce production. The American system could deliver quality tailored to specific tactical problems, on demand and at industrial scale. The entire supply chain functioned as one continuous, highly adaptable machine, from chemical compound synthesis to field fabrication of compression tubes. The ultimate irony was captured in post-war analysis by the Strategic Bombing Survey. SS confidence in their material concrete was based on fundamental misjudgment. They misunderstood America's material science and its ability to rapidly weaponize discoveries. Germans, constrained by limited resources and rigid centralization, could not react. They could not produce counterweapons, nor could they disrupt the flow of specialized rounds. Brigadier Heinz's failure was German industry's failure. They could not keep pace with American innovation and logistical flexibility. This firmly establishes T success as victory for American industrial depth. The narrative moves beyond individual heroism to systemic advantages they represented. The intimate nature of the T system raised immediate ethical questions among Allied staff. Penetration followed by immediate internal defeat was unlike other weapons. Unlike explosive force that offered random survival chances, the compression tube and thermal gas canister delivered near guaranteed death or incapacitation within sealed spaces. This specific mode of warfare became key discussion point in military chaplain reports. Post-war legal reviews examined it similarly to moral stress caused by flame tank operations. Military chaplains serving the division noted soldier reactions. While grateful for the life-saving nature of the T, soldiers struggled with the concept of sealed death. It lacked perceived cleanliness of bullets or distance of artillery. Sergeant Kendrick himself described the experience in later testimony. Hunting vermin in their holes. Necessary but deeply unsettling psychological burden. Knowledge that they were turning shelters into sealed pressure cookers caused considerable moral fatigue. This affected pioneer platoon members especially. Captured SS soldiers in interrogations frequently pleaded. They claimed subjection to inhumane weapons. However, military legal reviews conducted during and after war confirmed the T system's legality under international law. The key ruling established that weapons were legitimate responses to fortifications. These could not be effectively reduced by other means without excessive Allied casualties. The principle established was clear. Defenders' choice to fight from engineered enclosed military structures negated claims to protection from weapons designed to neutralize those structures. This legal precedent established at Neuchâtel directly influenced future doctrine. It affected counterinsurgency and urban warfare approaches. It confirmed that specialized penetration and internal defeat systems against military fortifications were acceptable under laws of war, especially when enemies actively avoided conventional confrontation. The psychological impact, however, remains the most indelible part of the T's legacy. Terror of facing weapons that respected no thickness of concrete and offered no escape contributed to unprecedented surrender waves. For the SS, the manner of death was as defeating as death itself. It was betrayal by the very earth and stone they had relied upon. The T became a symbol of total technological negation. The laws of physics replaced rules of engagement. This deepens moral complexity, ensuring the story acknowledges technology's full complex cost. Brigadier Heinz was not defeated due to lack of effort finding countermeasures. He was defeated because his enemy's innovation pace was simply too fast. Following initial loss of Fire Blocks 7 and 6, remaining SS units scrambled desperately for ways to stop the weapon. This shadow campaign of countermeasures was documented through recovered German field engineering notes. They highlighted increasing desperation. Their first attempt involved reinforcing bunker exteriors with sandbags and loose earth. They hoped cushioning would absorb kinetic impact of T rounds. This would prevent clean penetration needed for compression tubes. This proved futile. Shaped charges were designed to bypass soft materials. They focused energy directly on concrete. Added layers became useless. The countermeasure wasted valuable manpower and time. The second attempt was aggressive, but doomed strategy. Destroy T-teams directly. Colonel Volker commanded remaining armored reserves. He attempted deploying few remaining assault guns to ambush T-teams during their slow, precise advance. The engagement lasted less than 15 minutes. T-teams operated with standard Sherman tank cover fire. They used newly implemented seismic intelligence and were forewarned. 3 German assault guns were knocked out. Not a single T-launcher was damaged. Volker himself was later killed attempting retreat to remaining subterranean bunkers. The most telling sign of desperation was engineers' final flawed idea: internal flame barriers. Recognizing that compression tubes introduced fire and heat, Heinz's engineers attempted lining inner tunnels with ceramic tiles. They installed water reservoirs, hoping to extinguish thermal gas. This plan was still being implemented when T-teams targeted the main command post ventilation shaft. The plan wasted massive resources and was utterly ineffective against oxygen-depleting thermal gas. The crucial failure was one of intelligence and doctrine. The SS were still fighting last war's threats: explosions and direct fire. Americans had moved on to fighting the science of structures themselves. Germans' attempts at reinforcing defenses were merely attempts to build stronger cages against keys that were already cut. The Shadow Campaign was a race they were doomed to lose. It served only to burn through remaining reserves of manpower and material. The American industrial engine could innovate faster than German armies could react. Captain Vance's work did not end at the Riverless. His systematic methodology for target exploitation became cornerstone of post-war military modernization. T-system success demonstrated that specialized adaptable weapons were often more decisive than mass-produced generic ones. Following hostilities' cessation, Vance was tasked with leading the Army's newly formed Specialized Ordnance Development Section. Lessons from Neuchâtel were immediately applied to destroying Soviet-style concrete fortifications anticipated in Cold War conflicts. The result was direct lineage of weapons focusing on precision breach and non-explosive internal defeat. The T itself was quickly replaced by lighter, more accurate launchers. But shaped charge principles were refined. The compression tube, Vance's great field innovation, evolved into sophisticated breaching charges. Specialized gas canisters were designed to neutralize personnel without massive structural damage. Technology found its way into early versions of shoulder-fired anti-bunker weapons. These remain standard issue today. The most lasting impact, however, was on doctrine. Military academies began teaching the Neuchatel method, the combination of seismic or acoustic intelligence to locate hidden targets, followed by precision penetration and internal defeat. This warfare concept of fighting simultaneously on and beneath surfaces became crucial for operations in Korea and later Vietnam. Tunnel and bunker networks presented similar challenges to concrete fire blocks. Vance himself was recognized as pioneer in military engineering. He later consulted on various civil defense projects. He applied knowledge of structural vulnerability to analyze and reinforce critical infrastructure. His victory was not just over the SS, it was over engineering arrogance that assumes any structure can be truly impenetrable. This legacy highlights enduring power of unlikely heroes. Engineers who understand physics over firepower. The T became prototype for specialized urban and siege weaponry. It proved American ability to learn and adapt on the fly was their single greatest asset. The broken weapon that SS ridiculed became ancestor of entire class of modern military ordnance, a permanent reminder that soldiers on the ground armed with ingenuity and industrial support are true architects of victory. The final verdict on Neuchatel operation is unambiguous. It was triumph of adaptability and science over static fortitude and courage. SS defenders were prepared for conventional battles, to fight until ammunition ran out or structures were reduced to rubble. They were not prepared for weapons that turned laws of physics against them, turning their sanctuary into lethal sealed environments. T success was embodiment of industrial arithmetic of modern war. Field ingenuity plus logistical priority plus material science trumped human courage. The German equation was based on obsolete factors of World War I siege warfare. The American equation accounted for new variables: metallurgy, fluid dynamics, and atmospheric pressure. Brigadier Heinz's final message was found in debris of his command post. It was perhaps the most concise acknowledgement of his defeat. We underestimated their ability to circumvent structure. American technology flows where our will cannot stand. This single sentence encapsulated complete psychological and strategic collapse. The SS, who valued will above all else, were defeated by flow of American industrial and scientific ingenuity. Today, when military analysts discuss European campaign turning points, riverless sector capture is recognized not for massive tank battles, but for this single surgical innovation. The SS believed their concrete afforded them ability to dictate engagement terms. The T system proved American industrial power dictated terms of physics. The broken derided T launcher, the paper tube, is preserved in museums as symbol of this truth. It is monument not only to lives it saved on Allied side, but to final crushing psychological defeat inflicted upon Axis forces. It stands as perpetual reminder that technological superiority wielded with surgical precision and supported by unshakable logistical backbone can overcome even most fanatical defense. The shot that killed them all was shot fired not just from launcher, but from combined industrial and scientific might of a nation committed to victory through innovation rather than mere determination.